Greetings, Earthlings. Well, today we're going to take another look here at the Keithley 171. I have pulled out, even though I said I didn't want to do it, I've pulled out this AC converter card or input switch card. They call it the switch card, but it's got the AC converter circuits on it as well. So remember, there's the op amp that was bad, and there's the bad op amp, so I have replaced it. I got some, oh, it's an LM301. I got those at Jameco. I've lost my pointer. I also replaced those two 10 ohm resistors on the input. Even though they're highly non-critical, they had drifted out of spec, so I figured, what did I say in a previous video, you know? It's like, I want to get it back to factory spec. So, we're going to reinstall that, then we'll start checking the power supply. We'll reinstall this board, check the power supply, because this was pulling it down before, and assuming everything's good there at this point, then I'll install the other cards and we'll proceed from there. One other thing I could point out, not an official pointer here. As I mentioned in the last video, that there was a socket, that chip was socketed, that op amp. The socket appears to be factory original, but it was installed upside down. So if you look at the socket, pin 1 is upper left, but the actual orientation of the chip is with pin 1 to the lower right. So if you happen to have one of these that you're fixing, be wary of that somewhere, somewhere down the line. 5 years from now or something, if someone else has similar problems. All right, we'll get it back together and check the power supply. All right, the card is back in place, installed. It's plugged in. So let's check the plus and minus 15. Powering on. Plus 15 is this turret. That's right on. Minus 15 is over here. That's pretty close. The only other thing that I can do here is measure across that resistor again to check how much current is actually flowing. 0.071. Okay, so that's well under 100 milliamps at this point. This is on the plus 15. That's even lower. I don't know. Okay, let's put it back together. Put the rest of the cards in. Because I think I've checked the rest of the cards, checked the resistors and everything. So we'll put the cards in and see what happens there and work on to the next problem, because I doubt that was the only problem. All right, and here it is back together. Ready to power on. I'll turn it around so we can see if it does the same thing as it used to, or if anything's any different. We'll power on. Well, see if, first of all, if it powers on. Yes, it powers on. And yes, it's still showing randomness. That's on DC. Ohms, that should be overload, because I don't have that jumper in. DC current, yeah, okay. So, oh, look at that. It seems more stable now, but still showing, not showing zero, definitely. So let me turn it around here. Check the power supply. Let's see if I can remember. I don't even remember where these are. I think that's minus 15. Yeah. Was this plus 15? Apparently not. Or if it's supposed to be, then that's the next problem. That should be ground. This is plus 5, as I recall. Yeah, that's pretty close to 5. Plus 15 is test point 2. Test point 2. Oh. Well, I did have it on the wrong test point. This is test point 2. There we go. Plus 15. Minus 15. Okay. All right, I had to print out the maintenance section of the manual. I don't remember whether I had previously printed that out or not, but okay. I got it now. So we'll just run through this check and see if maybe we can calibrate it. It's looking fairly stable. It's just there's some random number in there, so we'll go through this. Measure the plus 5 volt supply at TP14, and it should be within 250 millivolts. So where did I say that was? This one? So 250 should be 4.75 or better. That's good. Check. I'll check that off. If I can find a pen. If I can find anything here. Check. Okay. 15 volt supply. Plus 15 should be plus or minus 10 millivolts. Well, it is. That's 6 millivolts. Minus 15 should be plus or minus 10 millivolts. Well, it's not. Ha! Okay. So, let me get dangerous here. Well, that was interesting. I just shorted the plus and minus 15 supplies together. With my test lead. Oh, wrong way. Too far. Is this a wire wound? It's acting like a wire wound. There. All right. 2 millivolts. Good. Plus or minus 15. Check, check. 210 volt supply. Measure the, okay. On the motherboard. Well, I'm not going to worry about that too much because, first of all, it's not adjustable. And secondly, the Nixies are indicating, so we're going to skip that one for now. Okay. Calibration should be performed in a controlled environment of 25 degrees plus or minus 1C. Well, it says 23 up there. That's close enough for me. 1 hour warm-up. Well, it hasn't. Use the special calibration top cover provided with the extender card kit. I don't have that. Perform all operations only in the order specified. Okay. Do not move the 171 while calibration is being performed. Okay. Reference element. Okay. Unless an inputs are specified, the input high should be shorted to the input low with a pure copper shorting plug. Well, I don't have a pure copper shorting plug, but I have this thing. Shorting bar, so I can put that on there. And we don't need to be super precise at this point. This is just a first pass to see if there's another problem. Okay, DC voltage mode. Select the DC voltage function. I have done that. Zero just driven guard, slide access cover. Okay, so this does want the shorting bar in place. Okay. And let's see. Ooh, using null detector on the 100 microvolts full scale range. I've got a null detector. Here it is. Using null detector on the 100 microvolt full scale range. Well, we're going to start on the 10 volt range because that's what it said. Differentially monitor between TP15 and TP16. All right. We're several millivolts off. We need to be within 10 microvolts, so let me bring that down. Adjust R527. R527 is way over here. Let me see if oops, this one. Well, this is fun. Here's the 100 microvolt scale. I'm not so sure it's supposed to be doing that. Let's try to get it in the middle. That's bizarre. All right. DC balance, okay, slide access cover B to the middle position. Range switch to, oh, you know, I don't know what range I was supposed to be on for that. Wonder if that makes a difference. Let's go back there. Oh, yeah. 100 millivolts full scale, okay. That's where we're supposed to be. Okay. Now we're on the 100 microvolt full scale, and that's pretty darn close, yeah. Yeah, okay. All right. So that's done. Okay, now. Null detector on the 10 microvolt full scale runners. Monitor the analog output. That's on the back. So that would be relative to ground. All right, here's some small progress. What I've done is I have removed the analog board from the meter. There's the analog board. So now it has 0 volts feeding the analog to digital converter. And I've got it reading about 0. I did tweak things a little bit. I'll probably have to mess with them again. I may have thrown it more out of calibration than in. But that's all right for now. Okay, so what I've done is I have, there's an output on the back, which is analog out on the back panel, analog output. Since there's no drive from the, let's see if you can see that, yeah, from the analog amplifier board, because it's not there, I can put a signal in there, a DC voltage in. Okay, so I've got it hooked up to the Fluke 343A voltage calibrator. Okay, got this set on the 1 volt scale. And so if I give it 0.1 volts, .0997, that's pretty close. Okay. 0.2 volts, 0.3 volts. Whoops. And hopefully you're seeing that on here, what the actual voltage is. Yeah, except when the lead falls out. Okay. So you can follow along. 0.2 volts, 0.11, 0.1998, 1 volt. Okay, that says 1.02, 0.81. Okay, so, you know, certainly the integrator needs to be calibrated, but it's basically working, which tells me the problem is in that analog board. So I'll have to work on tracking that down. But I think that's going to be another video. The next video will be fixing this board. So in this video, we verified the op-amp replacement, the fixing the AC converter, and then track down the next problem, at least at the board level. So that'll be good enough for one video, I think. Not to make them too long.